Last time we stopped here. We're still talking about the fundamental of casting. We was talking about the casting, and last time we discussed about the two type of the casting, which is expandable mold casting and permanent mold casting. I hope you remember. Expandable mold means that you use the mold only for one time, usually made of sand, plaster, ceramics. We discussed that last time. Permanent mold, the mold made of metal. Actually, we're going to discuss both. So mold made of metal, usually metals, as we said, cast iron, steel, bronze, steel, and die steel, and so on. And here, this one be used for several times. This only one time, this one several times. And previous class, we discussed about the advantages and disadvantages in each case, and where this one is important and where this one can be used as important in a casting process. This what we discussed. So expandable mold process and permanent mold. Also, we discussed the several processes under expandable and permanent. And we said that this kind of processes under expandable mold and permanent mold, we're going to discuss in detail in chapter 8, next chapter, right? Next chapter, chapter 8. Overview of the casting. Casting, the place we use to make casting, we call it is a foundry. So foundry is a place to do the casting, we call it foundry, and the person who working with this casting, we call him as foundry man. That's what we discussed last time. I hope you remember that. We almost stop here. So sand casting, and we'll start discussing now or talking about the exactly on the sand casting under the expandable mold casting. We're going to discuss about the sand casting. Sand. The word sand meaning we're going to use the sand to do the casting process. You know, sand is free. You can just get for free. Definitely not only sand, but sand plus some other additive. We call it is a green sand. Green sand is means that the word green here not because of color, but green here because it is mixed with a small amount of other material and moisture. Moisture mean water. That's why they call it green sand, but it is actually not green. Usually it is brown because sand, it's made of sand. Sand is, you cannot use sand only to create the cavity in the mold or create the mold, because the permeability will not be, sand is not permeability material. Yeah, you cannot withstand or you cannot create shape or maintain the shape in the sand, so you have to add it some whatever we call clay and so on. So clay and some other additive, I mean chemical additives and some water. So that's why they call it green sand. This sand being used, as you can see here, whatever we call flask. This whatever we call flask. Flask is a container. We put the sand in the flask, and then we put the pattern. You put the pattern, you create the cavities. This is whatever we call pattern. Initially, to explain to you, initially, the first step is to create the pattern. What is a pattern? This is very important. Pattern it is exactly similar geometry and dimension, part made exactly similar to the geometry and dimension of the parts that you would like to produce at the end of the casting process. Made of what? Made of anything. Made of wood, made of metal, made of plastic. Just we need to create that pattern to create the cavity in the mold. So the functionality of the pattern is to create the cavity in the mold. So initially we manufacturing the pattern. Someone asked me how to manufacturing pattern manually, maybe by using machine, whatever. It doesn't matter. Right? So first we create the pattern. This is a pattern, and then cut pattern twice. Twice mean half up, half down, as you can see. And this pattern, we use it to create a cavity in the mold. As I told you, it is made of sand. So we put the sand, first step, we put the sand in here flask to fill the flask. And then we bring the pattern and we put the pattern in the sand. When you put the pattern in the sand, then you create the cavity, and then you take pattern out. You take the pattern out and leave the cavity here. You take the pattern. Initially, you put the pattern in up and down. One for up. This is the up and down. We have two mold. There are two mold, up and down. We create two mold, up and down. One of them, one half for down, one half for up. Then you create the cavity in here and up and down. And finally, you assemble this kind of mold, then your cavity will be created. So this whatever we call pattern, right? When you put the pattern in the sand, if it is only sand, it doesn't work. You must add some additive so it can create a plastic. You can plastically deform to create the cavity, right? So you put here, you create the cavity up and down. So this is symbol of the cavity. This is the cavity below, up and down. This is the upper mold, this is the lower mold. You create the cavity up and down, and finally we create a cavity up and down by using the pattern. You assemble mean you connect up and down in one part, and then you put the liquid. This is the assemble here. You can see when you assemble the up and down, the upper and lower mold, then we said we call it mold. Just remember, it is a mold. Mold means the material that you manufacturing this kind of parts that you need to create the cavity inside. This whatever we call mold. Then when you do the assemble here, you get the cavity inside. Then you put the liquid. When you put the liquid will come and fill all the cavity. Liquid will come inside and fill all the cavity. As you can see, when it fill all the cavity, then liquid fill all the cavity. You leave it for a while to solidify. When it solidify and become solid, you destroy the mold, because this is expandable mold made of sand. Then you destroy the mold, you take the part out. You destroy the mold and take the part out. Any question? Is it clear? This is the steps how to manufacturing. Should we remove the pattern? Yes, as I said, pattern, initially we put a pattern to create the cavity. Later you need to remove, must remove. If you didn't remove the cavity, the pattern, how to get the cavity? You must remove the pattern only to just put to create the cavity, and then you remove it. When you remove, you get this one. Can you see here? This one is a cavity after you remove the pattern. What you need here is a cavity. You remove the pattern, only get the cavity. So cavity is here. Any question? Is it clear?
Yes, clear.
Okay. Yeah, sure. If you would like to ask me anytime, you are very welcome. If you don't understand. So this is the steps actually. There are many details coming, but this is the steps on how to create the cavity, how to create the mold, how to create the cavity, how to pouring material, and how to cast the material. This is the steps. Right. Okay, let me just... Okay, so details of the mold. This whatever we call is the mold. Can you see that? This is the mold. The details of the mold. What we call it. So this is the details of the mold. Here the mold is this whatever we call is, let me just magnify. This is whatever we call Pising cup or pouring cup. Pising or pouring cup. This is a pouring cup. This is whatever we call sparrow. This is a channel to bring liquids. When you put the liquid will move in this channel. We call it is a sparrow. This whatever we call is a well. This is a gate. This is a well. This is a runner. This is a blind riser. This is the main cavity. This is the main cavity here. So this is the main cavity here. This is the core. This is the open riser. This is the open riser. This is the vent. This is the open riser. The upper half, we call it cup. The lower one, we call it drag. So now, from now, cup and drag. Upper one, we call it cup. Lower one, we call it drag. The container here that you put in sand inside, we call it flask. The container that you put sand inside, we call it flask. This is a parting line. Parting line means a line separating up and down, or cup and drag. From now, it is cup and drag. Definitely all material inside is sand. Sand actually is very high melting temperature material. Then it's good material. You can just cast any liquid inside. I mean metal liquid inside, regardless what is it, because sand can withstand very high melting temperature. That's why sand be used as a material to manufacturing the mold. Right. One by one, just give me your attention, please. Please give me your attention. Right, one by one, let's just understand what every item here. Actually, this is very important to understand every item in a mold. This is a Weizen cup. This is very important. It's big compared with the Spiro. Spiro is a smaller diameter, this one big. This allow material, when you bring the material is to come from bigger size to smaller size. Then easily can just go inside. So we call it is a cup or Weizen cup. It is big compared with the Spiro. This is a Spiro. Spiro here is a channel to bring liquid to fill here. Actually, this is the main part. This is the additional part we create. This is very important to how to bring liquid inside. Then you need to create this kind of a channel. So this we call a Spiro. Spiro is the main channel to bring liquid inside. This is the well. The functionality of the well, actually, then liquid come inside to fill the well. Well, here the functionality of the well is important because liquid is accumulated and flows smoothly to the runner. Not directly go, because this one probably can damage or destroy the mold. You have to create the well. Well functionality is to accumulate the liquid smoothly get into the runner. Runner is a channel to bring liquid from here to the main cavity. This is the main cavity, right? This is the main cavity. In the way, there are a blind riser. I will leave it for a while. Just leave it for a while. This is the main cavity. This is the main cavity. This is the core. This is a core here. This is whatever we call is a core. So this is the main cavity. This is the core. The main functionality of the core is to create the internal surface. The main functionality of the core is to create the internal surface. Let's go back to the previous slide. Can you see that? This is the core actually. The liquid here will fill around the core. The core here will prevent liquid to fill this area. And later when you get this one solid, you remove the sand from inside. So core here functionality is to create internal surface or hole inside. This is the functionality of the core. Is it okay? So you put the core here, then liquid will fill around the core. All this area will not be filled with the liquid. Later, because it's made of sand, so later when the part solidify, take this part out, you remove sand from inside, then you get the cavity or you get the hole. So this is the core. So this is the core inside. This is the main cavity. So liquid will fill around the core. You destroy the core, later you remove the core, then you get the hole inside. This is the open riser and this is a blind riser. So what is the blind riser and what is the open riser? Blind riser, just listen to me carefully. Blind riser, the functionality of the liquid will fill the blind riser. Liquid will come and fill the blind riser. The blind riser, the main functionality of the blind riser is to deliver liquid to compensate shrinkage when this part solidify. This is the riser. This is a blind riser. Blind riser functionality is to bring liquid to bring liquid later when this one solidify, to compensate the shrinkage when the main part solidify. هقول بالعربي. البلايند رايزر مهمتها يا شباب انها تعمل ديليفر للليكويد عشان تعوض الشرينكج اللي بيحصل في المين بارت، عشان تعوض الشرينكج يعني الانكماش اللي بيحصل في المين بارت نتيجة solidification. Someone will ask me, is it made of same material? Yes, this one is same material. Then both solidify at same time. The blind riser, the liquid in the blind riser and the liquid in the main part will solidify at the main time simultaneously. So how this one can deliver liquid when this one solidify? Because if this one solidify, it means this one solidify as well. Then how to this one to bring liquid to compensate shrinkage happen in the main part? Actually, it will happen. We design the riser in a way, listen to me carefully, we design the riser in a way to maintain the liquid for longer time to deliver liquid when this one frozen. It means in another way I say that the main part solidify earlier, this one solidify later. So this riser will maintain liquid for longer time. How come? That's what we're going to discuss in details when we come to the design part. When we come to the design part, we will discuss the design of the riser and we will see how to design the riser to maintain liquid time. Not only that, but also how long time we can design the riser and we can control actually the time and see how to design it to maintain the liquid for longer time. So riser can work like a reservoir to deliver liquid to maintain or to compensate shrinkage happen in the main cavity while solidification. This is the functionality of the blind riser. We call it blind because it is closed. This one we call it open riser. So this is a blind riser. This is the open riser. Open riser almost have same functionality, but additionally, this open riser, we can see the liquid when the liquid just when the liquid move out, we can know that casting already completed. When you bring liquid here, the liquid will fill all cavity and the liquid will move out from here. When we see the liquid move out from this side, you can see that liquid will come fill all cavity. When liquid fill all cavity, it will get out from here. We can see it. When we see the liquid here, we realize that liquid fill all cavities, then we stop bringing liquid or delivering liquid or pouring liquid inside. Remaining is the vent. What is the vent? The vent actually is the channel. We make this channel to release the air, because there are air inside. When you put liquid, there are air inside. We need to release the air, so air must escape. Otherwise, if you didn't put any mean to release the air or release the gases, not only air actually, but also gases, because when you put hot liquid metal inside, it is very hot, maybe 1000 degrees Celsius or more, then immediately many gases will be created because this one cold. There are many moisture inside, so vapor coming and gases, smoke coming. Then this smoke must be released, must move out. If this gas is not move out, create bubbles inside. Bubbles يعني فقاعات هواء inside the main cast, and this one lead to big defect. We cannot accept that. So we must create some channel to release the gases, right? We put whatever we call vent, and vent must be put in that top point, the highest point, not here because the core is here. Top point in the main cavity. This is the highest point in the main cavity, so it must be here, right? So gases will move. Gases, when you put liquids, these gases will move, and then vents and gas will release, and the other gas will release from open riser. So open riser also being used to release gases. Vent also being used to release gas. Probably maybe more than one vent. You create. So gases will be escaped from here and also from here. So this one can done perfectly without any problem with or worry about the kind of gas trap inside and create uh, bubbles in the main cast. Any question? Is it clear? Do you
Yes,
understand the
clear.
functionality? Any
Clear.
question?
Yes, clear يا دكتور.
Right,
Yes, sir.
because this is very important. This is very important. Later, you have to remember what I said. So, because we're going to design every single details here in the mold. So, you must understand first what these items. So, later you will be able to know or to understand how to design every single item in this one. Right. This is a mold. We call it is a mold again. This is a two views. This is a 3D view. This is a 3D view. This is a two view from same. Then let's agree now. This is a mold. We call it is a mold. This one is a flask. The blue color one is a flask metal made of metal maybe. So this is a flask container. This is the upper and lower. We call it cup and drag. So this is the cup. This is the drag, right? Upper and lower. Cup and drag. This is a bison. This is a bison cup. This is a sparrow. This is a well. This is a runner. This is a runner. This is a blind riser. This is a main cavity. This is a main cavity. This is a vent. This is the open riser. This is the open riser. This is a core, right? So this is the detail of the mold. Okay, that's what you get when a part will solidify. When you put the liquid, liquid will fill all the cavity. The liquid will fill all the cavity, and then you leave it for a while. Then liquid will solidify. After liquid solidify, you destroy the mold. You destroy the mold mean what? You destroy the sand. This is made of sand. Then you remove the sand. Then you get the part or the casting part. This is the part made by casting. So this is the part. You can see that the gray color here is the part that I would like to have. Additional material you can see. This is a runner. This is a riser. This is a sparrow. This is a Pising cup. This is a Pising cup. This is a sparrow. This is a runner. This is a well. This is a runner. This is a riser, blind riser, right? And main cavity. This is the main cavity. This is a part, and this is the open riser. So this is extra material. This one, this one, this one, this one, extra material. Actually, you need to cut. You need to cut here. You need to cut. This is extra material, and you need to cut here. This is extra material, right? Then you need to cut here. You need to cut here. This is a part. This is a part that I would like to have at the end of the process. This one is extra. This one extra. No need. And when I said that we can eliminate from beginning, we cannot. Unavoidable. You must have it. You must have sparrow, boring bison, you have runner, and this kind of thing. This detail must be there, how to bring liquid inside. You must create this channel to bring liquid inside, and the open riser also as well. So it is unavoidable to have this kind of additional material. And you need to cut, probably you recycle. Recycle means you put in a furnace, you melt and reuse again later to create another part, right? This is here is it's written, what we just discussing is written here. This is a flask. This is a parting line between cup and drag. This is a cavity. This is a gating system. This is a boring bison. This is a sparrow. This is a riser. This is a runner. This is a gate. This is a vent. This is a core. The item is written here. I already explained, but it is also written here. Then you can just read it later and see what that means. Right. Mold and mold making. Now we talk about mold and mold making. This is a mold. You remember all time, this is a mold. So mold and mold making. Now we talk about sand mold. Sand mold. Sand, whenever we said sand mold, meaning mold made of sand. So made here, the mold made of sand. Actually, not only sand. This one, as I told you, we call it is a green sand. We call it as a green sand. However, it is not green. The green word green here, not because of color is green. It is because of the adding moisture and some additive. So we call it green sand. However, it is brown in color. It is, as you can see here, it is usually brown in color because we put clay. Clay اللي هي شباب يعني الطينة. in Arabic يعني الطين طينة. فلما تحط الطينة على الساند لونه يلو، لما تحط عليه الطينة اللي هي البراون usually become like brown. So it is silica أو sand plus clay plus water and some other organic additives to improve the characteristic of this one. So this kind of mix, and then you mix this one, then you create the sand. Percentage is 70 to 80% sand, 10 to 20% clay, طينة, 3 to 6% water, 1 to 6% additive to improve the properties of the sand. So finally you made the sand. When you create the sand based on this, it become like a plastic material. Plastic material mean when you can easily create a cavity inside. You can easily create the cavity, not only create the cavity, but also maintain the shape. Create the cavity and maintain the shape. So you put liquid inside. The mold properties by green sand, this one. What is the properties? What is the mold properties by green sand? Should meet the following requirement. First one, refractory. This one must be refractory, made of refractory material. What is refractory material? The word refractory material mean this kind of material that we use to manufacturing the mold must be higher melting temperature material, mean withstand higher temperature. Then this is the mean of refractory. So the word refractory mean higher withstand higher melting temperature material. Ability to withstand higher or high melting temperature material. Sand is perfect because very difficult. Can you melt sand? No way. This one can withstand very high melting temperatures, and it's good to use the sand as material to manufacturing the mold. Right. Strengths. The next properties is strength. Strength is have ability to withstand compressive strength because you put liquid inside. When you put liquid inside, this one apply pressure on the sand. So it must have enough strength to withstand, compressive, enough strength to withstand the compressive strength. And this one done by clay and moisture. When you put clay and moisture and additive, this one gives sand. Sand alone not working. But when you added clay and moisture and the other additive, organic or inorganic additives, right, become plastic material, and then this kind of additive gives strength to this, the sand then become whatever we call have enough strength to withstand this pressure coming from the liquid when you do the pouring of the material. Next, flowability. Flowability is a word. Flowability, it is the ability of sand to flow around. When you put the pattern inside, the sand will flow around to create the cavity. This one we call flowability. Flowability, ability of sand to flow around. Around what? Around the pattern. Around the pattern. And cover the pattern when the mold is removed. Then create the cavity. Then this is the flowability. If it is solid, how to put the pattern inside. If you don't have flowability, then how to create the cavity? No way, because if it is solid and very hard, rigid, you cannot put the pattern to create the cavity. So what we call is the flowability. Next, cohesiveness. Cohesiveness is the ability to retain the shape, as you can see here. When back in the mold, when you put back in the mold and put the pattern, this one maintain the shape, not destroy. Because if if don't have cohesiveness, when you take the pattern out, immediately it will collapse. But if you take the pattern out, the shape remain. This is what we call cohesiveness, right? Collapsibility, easy to destroy and take part out. Easy to destroy and take part out later when solidification happens. Permeability is the ability to permit air to escape, not only from the vent, but also from the between a particle. It means that the particle here allow gas to escape through. When I said how this come, we usually use sand with different particle size, small and big size. Then this one make like cavity in between. Then later on when you use as a mold, then this one allow gases to trap inside. Not only in here you can see that this is the area to evacuate the gases, but also here between the particle also allow gases to escape. This one, it could help also to release the gases and improve the quality of the cast. This is the properties must have, or the mold must have or should have for good quality cast, right? If you don't understand anything, you can stop me anytime, definitely. Property of sand casting. Sand casting, in sand casting, the mold cavity must have desired shape. This is a mold cavity must have desired shape. The shape of the bars that you would look to produce the green sand must have desired refractory characteristic, which is withstanding high melting temperature. Provision for air gas trap here, like here we have vent and also we have open riser, and the particle size is different, then it can allow gas to escape. Provision made to prevent no shrinkage, no restriction in the shrinkage, and provision for removal of casting from the mold. How to break, how to destroy, easily to destroy the mold and take the part out. This is a conclusion. Type of sand mold. Sand mold, here sand being used in molding. We have whatever we call green sand. We have whatever we call dry sand mold and skin dried and cold box and no back. This is the sand type. Actually, green sand, you know that it is sand moisture 26%. You added clay, sand, and clay. As we described, it is a green sand. However, this one, if you we have whatever we call dry sand, mean we have a torch and we use a torch to remove this kind of moisture from sand. Why? Because they said that whenever you have green sand with moisture, when you put the liquid inside, a lot of gases will be created, and this create, or we have big problem because of that. Then the dry sand is made using organic binder rather than clay. This is the first one, and better dimension control. Usually is backed at 200 to 300 to remove every moisture, and made of organic binder rather than clay. No clay. This one made of clay. Here we remove clay and put organic binder. Binder mean كلمة the word binder يا شباب معناها انها attaching the sand particle together to make it plastic material. So we use organic binder, يعني مصنع binder مصنع زي جلو كده مصنع عشان يخلي الساند ده attached to each other and يخليه plastic material, and we don't use clay in this one, and we pack it at 200 to 320. This glue will be activated and remove every moisture. Why we do that? To remove the moisture from the green sand, because the moisture here creating moisture اللي هو الميه يا شباب. يعني الموisture here creating a lot of gases and smoke coming, and this one probably lead to many defect in a casting. However, you increase the cost because this kind of organic binder increasing the cost. The other one is skin dryer. Skin dryer is drying the green one. The green one here we dry it. Green sand mold. We dry the green sand mold by heat. We heating the green. We bring the green sand mold, this one, and we heat it. We heat it by using something like a torch until depth 10 to 5 to remove the moisture. As I told you, removing moisture could be beneficial because this one creating a lot of gas and smoking when you put the liquid inside. We have cold box and no back, and both are synthetic material, different synthetic material, but definitely this one increase the cost. So higher cost associated with the cold box and no back, and in this way quality will be improved actually. So accurate but expensive, as you can see. It is synthetic material, it is accurate, but it's more expensive. This one cheap actually, this one free, but this one costing some money. So this is the big difference between the different type of sand being used or material being used to manufacturing the mold. This one flowchart describe what happened. You create a pattern, and then you need to create the mold. You need to have the pattern and sand. You put sand and pattern. You put sand and pattern to create the mold, and then you get liquid metal. You bring the mold and you put liquid metal. You pouring liquid metal, and then solidification, and so on until you get inspection and check the part and so on. Probably you do heat treatment after the casting process. So this is the processes from the beginning to the end to do the casting in metal. Pattern, when you come to the pattern, actually when you see the pattern, how to preparing pattern to create the cavity, there are many steps. There are some steps to prepare the pattern to create the cavity in the mold. First one, you need to manufacturing the pattern as we call it solid pattern. The first step is solid pattern. Second step is split. Split pattern. Split pattern, you mean cut twice, up and down. As I told you, we need to have one for up, one for down, and then you fix on whatever we call plate. Match plate pattern. You bring two plates, one up plate and one down plate. You put in a plate. You put a pattern in the plate. Why we do that? Because we need to assemble here. This is a riser. This is a runner. This is the additional part we need to add it. This is a riser, this is a runner, this is whatever item here for up and down. Then you have two plates, one plate for up, one plate for down, and then we added all details. Then when you put in the sand, all these details will be created in the sand, right? This one usually made of wood, يعني من الخشب، بيتصنع من الخشب. And some cases made of plastic, some cases made of metal, and so on. Then the main functionality, you create these plates, then you put in the sand to create the cavity. This is a pattern made or pattern preparation. We have whatever we call a pattern allowance. We have what we call is a pattern allowance. What is the allowance? Actually, the pattern, we create the cavity by using pattern. Then cavity will be created exactly as the dimension and geometry of the pattern, right? However, liquid will fill the cavity. Liquid is a bigger size, and later liquid will solidify and shrink. shrink يعني shrink يعني ايه بالعربي؟ shrink يعني ينكمش تمام؟ يتقلص او ينكمش تمام. يعني هو بالعربي زي ما نقول احنا الليكويد هيملى كل الكافيتي تمام، وبعدين لما يبرد في التبريد هينكمش، هيبقى حجمه اصغر. ففي الحاله دي الدايمنشن بتاعته هتصغر. يبقى نعمل ايه الحل؟ the solution is you have to make the pattern bigger size. You have to make the pattern, manufacturing the pattern as a bigger size. Then when you create the cavity, you create the bigger size cavity. When liquid fill bigger size cavity. And then when shrink, it shrink to the okay dimension, okay, not smaller size. Otherwise, if the dimension is smaller size, will be rejected. This what we call is allowance. Then we have to make allowance, added allowance to the dimension. If you would like to manufacturing, for example, dimension diameter is 100 millimeter diameter, you have to make it in the pattern. If finally you would like to have for example 100 millimeter diameter, then 100 millimeter diameter you must make it like 110, for example 110 millimeter in a pattern. You have to manufacturing pattern with 110. So create a cavity with 110. When you put the liquid, it will fill 110. But when shrinkage will happen, it become 105. Then should be okay. If you make it 100, exactly 100, then cavity will be 100. You put liquid, will fill 100. When shrinkage become 90 or 95. But we need the 100. Then no way, it will be rejected. Then you have to add some more dimension. We call it allowance. Then this is whatever we call shrinkage allowance. This is a shrinkage. We need to add it shrinkage allowance. What else? We need to add it also what we call machining allowance. Machining allowance because after casting finish, we need to do machining. As I told you, we need to do some machining. We need to do some removing some layer. This one I told you last chapter. We need to do after cutting, after casting, we need to do machining. Machining means cutting. We need to remove some layer from the casted part to bring or to determine the precision and accuracy. Then you need to add some additional dimension for machining and some other additional dimension for shrinkage and some additional for distortion, because material, you know that any material you heat and solidify, some distortion happen, so you need to improve the distortion. Then you need to add some material for also machining to remove the distortion. And finally we have whatever we call is the draft allowance. This draft allowance we added to create taper dimension in the cast for easily removing from the mold after casting. This one I will discuss later about this kind of allowance and how to actually add it, how to design for allowance and how to add it, this kind of allowance when we come to the design part. Then we have to agree now at the time to create the pattern at a bigger dimension. Let us agree now at this time to create the mold at bigger dimension. So later when shrink happen and machining and so on, dimension will become acceptable, not rejected. Right, so details of allowance I will discuss in the design part. When we come to the design and the numerical part, I will describe all these kind of details. Yes, Saud.
Doctor,
Saud.
uh,
Yes.
what is the point of the riser if we has to put allowance
Again, your question, what is the point of what?
of the riser
Riser.
if we have to
Ah,
put allowance?
shrinkage allowance, right. Yeah, this is good question. Saud asked a very good question actually. We put riser, right, excellent. So, but we still put shrinkage allowance. Why? So, what is the functionality riser? We put riser to compensate shrinkage when now we put shrinkage allowance. What happens, Saud, if riser not working for any reason? For any reason, if collapse happen, if riser doesn't work for any reason, you design it, perfect. But now, when we do the casting, riser not working, what is the solution? What do you think what will happen? We have to scrap this material, right? Then in this case, it's better to make double factor or double safety. Put some shrinkage allowance and riser as well. If riser working, we didn't lose anything, fine. If riser not working, then shrinkage allowance can solve the problem. Did you get it?
Yes, thank you.
Yeah. Because actually it is a complicated process. It is not that simple as we describe. Could be anything could be happening. You cannot see, you cannot understand what happened below, under the surface or under the, because it is, you see, you cannot see while it happening. So they do like this to be sure that casting will done perfectly without any problem. Okay, pattern material. Pattern, what material we use to manufacturing the pattern? Actually, pattern could be done, as I told you, from many material. Could be done from many material, like wood, like plaster, like aluminium, magnesium. I mean metal, wood, plastic. Uh, Several type of material can be used to manufacturing the pattern. Pattern are coated with the parting agent. Parting agent, there are some silica. We coat the pattern with some parting agent to facilitate remove, because you put the pattern in the sand to create the cavity and then take it out. To facilitate the motion or to remove this one from the mold, we coat with whatever we call the parting. There are some special parting agent to facilitate the removal of this one from mold easily without destroying the mold. Right. Core. Next is the core. Core actually, you know, what is the core? The core is made of sand also as well. If you see here, core is made of sand. We put the core inside. Why we put the core inside? This is a cup. This is drag. This is now cup. No upper and lower now anymore. Cup and drag. Huh? Cup and drag. This is a cup and this is the drag. We assemble cup and drag and we put inside core. We put inside the core. Why we put the core? The main functionality of the core here this is the core, a liquid will fill around, and later we remove the core, then create the hole inside. The main functionality of the core is to create the hole inside. We call it internal surface. So liquid will come, fill everywhere, and then you create internal surface as you can see. There are many issues here. First, core made of sand. Core made of sand. Then easily you remove the sand from inside to create the cavity. This is one. Second, core is really complicated. It is very complicated to add the core. Let me tell you, listen to me carefully, please. Listen to me carefully. If you can remove the core and don't use the core, please do it. It is complicated to add the core. It's better if you don't use the core. It is better if you don't use the core. So if you can avoid having core inside, it will be better. Someone said, okay, remove it and just do machining. Sometimes dimension very big. And then you lose a big amount. In this case, you must use the core. So it is case to case. If the dimension is small, then probably you can remove the core and use cutting or machining to make the hole, to drill the hole inside. But if the dimension is very big, or are the dimensions, the whole dimension is big, then probably core is essential and you must use the core. If needed, if you must use, then use it. If must use, then use it. But if you can avoid, then avoid having it. Then it will be better to not use it. All right. The core here, you can see here, it is supported here. It is set here. What here is cantilever. If you put liquid destroy, this one will be destroyed. That's why I said it's complicated. If you put liquid inside, it could destroy the collapse. The core will be collapsed. So what to do? We added this kind of bolt inside. We call it chaplet. We added a chaplet here. This is a chaplet and here chaplet. We call chaplet. We added chaplet up and down to support the core in this side. If you didn't put chaplet, then this one will collapse and no way. You will not be able to have the internal dimension or hole in anything. You must add a chaplet up and down. This is chaplet made of same material, same liquid material. Then if you cast steel, you put steel. If you cut aluminum, you put aluminum and so on. Then when the liquid will come, liquid will fill all cavity and liquid will fill around, and then finally, initially chaplet will withstand the temperature and support, while solidification, the chaplet will be one part of the cast material. Additional material will remain here, you cut by machining later. Then it will be part of material. Finally, it will be homogeneous and will be liquid. It will be melted in somehow and will be part of the material and will be no issue. Chaplet must be used to support the core in case of having this situation. Any question? Perfect. Okay. This is several type of core design, but finally the main idea, this is a core made core, this is a core box. Easy to remove the core later, very easy because it is made of sand. Core made of sand, then simply what you have to do is to remove the sand from inside, so it's very easy. This is the core box to manufacturing the core. Core will be, and when you take the part out, core made of sand, then simply you remove the sand, then you get the part with the dimension. Next, we talk about the temperature in casting. Temperature in casting. Actually, time is almost finished. I have to stop here and to continue discussion about this one next time, inshallah.